Oh, hi class, this is Professor Smith. I'm going to be doing a word problem on involving the maximum or minimum of a quadratic function. In this example, we have a ball thrown vertically upward after t seconds. Its height h in feet is given by the quadratic function h of t equal to 88t minus 16t squared. What is the maximum height that the ball will reach? So I'm going to use one note to capture how we would do this problem. We notice that we have 88t minus 16t squared equal to h of t. This leading coefficient of negative 16, because it's the coefficient of t squared, that lets us know that it's going to be opening downward. We also know that it's a parabola because it's quadratic, t squared. So I'm going to open up OneNote to graph that. So we have the horizontal axes, and now what I'll do is do my best to draw a parabola. Don't laugh at my beautiful work here. Oh my goodness, you know what? I have been doing the normal distribution in my statistics class. I drew the normal distribution. Let me try that again. All right. So here's our parabola. It's always symmetric about its line of axes. So I'll graph that as well so we can kind of get an idea. So this is the axis of symmetry. And we can find the value of that axis of symmetry by using x equal to the opposite of b over 2a. So I will open up math type so I can show you that. So now that I have it open, we use the formula x equal to the opposite of b divided by 2a to find the x value of the vertex. But since this function is in terms of time, it would be more appropriate to write it as t equal to the opposite of b over a rather than x. So we're going to substitute in our values. B is the coefficient of the t term, so it's going to be the opposite of 88 divided by 2 times negative 16. And when we take 2 times negative 16, we get negative 32. Actually, you know what we could do? We could cancel the 2 and the 88 and do 44 over 32. Yeah, let's do that. So we have a negative and a negative, so it's going to make it positive. And then 2 goes into 88 44 times, divided by 16. And then 4 goes into both those numbers. 4 goes into 44 4 times. Pardon me, 11 times. And 4 goes into 16 4 times. So we get that our... oh, you know what? We could use the calculator to do this. Yeah. We're going to get 11 fours. 4 goes into 11 2 times and 3 fours, so 2.75. So we could have used the calculator to get the 2.75. All right, so we would take the opposite of b, which is negative 88, divided by 2 times minus 16. And we get the positive 2.75. So that we get that that's t equal to 2.75. That gives us our axes of symmetry. So that lets us know that when t is equal to 2.75, make this just a little bit bigger so you can see. So when t is equal to 2.75, that lets us know, oh, it makes it capitalized. Anyway, when we have t equal to 2.75, that lets us know that's the time where we'll have its maximum height. How do we find the height? Well, just like we have t here for the x-axis, t for the x-axis, h, which would be the height, is going to be our horizontal axis, which you would normally think of as y. So the height is what we're going to find if we plug in t equal to 2.75. So let's do that. Let's plug in 2.75 into this equation. So we're going to have 88 times 2.75. And you could use the times symbol rather than using parentheses. Minus 16 times 2.75 and then squared. So we've just replaced t of 2.75 into our equation. And so we get a height of 121 feet. So let's check this. Got to make this a little bit smaller so I can find the check button. There she goes. Session is timed out. All right, now I was able to open another example. An aircraft factory manufactures engine airplanes. The unit cost in dollars to make each airplane engine depends on the number of engines made. If X engines are made, then the unit cost is given by the function C of X equal to 0.4 x squared minus 176x plus 24,758. What is the maximum unit cost? So in this particular case, our leading coefficient is 0.4 because that's the coefficient of x squared. So that lets me know that my parabola is going to open upward. So if I use OneNote to capture that, I would have a little bit different graph than what I have here. So I'm going to insert another vertical line and horizontal line. This time, this represents X, which is the number of engines made. So that's the x-axis, and that represents the number of engines made. And then the vertical axis is going to represent the cost. And so we'll call that our cost function. And that's based on the number of engines made. So in this particular case, it tells us that it's opening upward. So I'm not sure how it opens up, but something like so. And we want to find where its minimum value occurs. And so again, when we find that axis of symmetry, that's representing the low point. So this low point on the graph is going to give us our minimum cost. So again, we're going to find the vertex by the same way we did before. It's x equal to the opposite of b over 2a. So in this particular case, we don't have to change it to t because it's not a height function. And then we're just going to substitute in our values. For our particular case, x had a b of minus 176 and 2 times 0.4. So it's going to equal the opposite of minus 176 divided by 2 times a, which was 0.4. Usually when we have a double negative, we usually put parentheses around it just for a proper way to write it. But since we're going to be using the Alex calculator anyway, it's okay. We know our answer is going to be positive, but let's just go out there and capture that. So we're just going to type in the opposite of negative 1, we're just going to write in 176 divided by 2 times 0.4. We don't need the minus. We could put the minus in, but a double negative is positive, and this is intermediate algebra, so we can handle it. So we know that when we produce 220 engines, then we're going to have a certain cost. So let's figure out what that cost is when we produce 220 engines. So we're going to do 0.4 times 220 squared minus 176 times 220 plus 24,000 plus 24,000, I have an extra zero there, 758. So let's make sure that we substituted that value in correctly. So the cost for 220 engines is 0.4 times 220 squared minus 176 times 220 plus 24,758. And when we do that computation, we get 5398. So I hope this movie on word problem involving the maximum or minimum of a quadratic function was helpful. If you need my help, feel free to text at 916-813-9027. Professor Smith signing off.